You've spent hours practicing in Packet Tracer, but in a real job, you'll be working with physical equipment, not just simulations. While Packet Tracer is a great learning tool, gaining hands-on experience with actual hardware is essential to truly mastering networking skills. In this episode, part of our CCNA series, I'm going to configure DHCP Inter-VLAN routing using a Cisco IOS router and a Catalyst 3850 switch. Once setup is complete, I'll test connectivity between VLAN using a PC to ensure proper network segmentation and dynamic IP assignment. In this channel, we focus on beginner-friendly tutorials, so I'll also guide you through the process of connecting console ports on both router and switch. Before we dive in, make sure to subscribe and share this episode so more aspiring network engineers can gain these essential skills. Let's get started. In order to jump into the configuration, let's first go over the network diagram so you can clearly understand how everything is connected. In this setup, we have two VLAN. VLAN 10 is assigned to IT and VLAN 20 is for management. Now let's take a look at our devices and connections. PC 1 is connected to switch port 1 and belongs to VLAN 10, and PC 2 is connected to switch port 2 and is part of VLAN 20. Finally, the switch itself is connected to the router through Gigabit Ethernet port 0. Now that you have a clear picture of the network topology, let's move on and check out our hardware setup. Let's take a look at our physical setup so you have a clear understanding of the devices we're working with. At the top, we have a Cisco IOS router, and at the bottom, we have a Catalyst 3850 switch. So router is connected to switch using an uplink connection from Gigabit Ethernet 0 on the router to Gigabit Ethernet 24 on the switch as shown on diagram. On switch side, we will configure trunking to allow VLAN traffic to pass between router and switch. Now that we understand our hardware setup, let's move on to connecting to the switch and router using the console port. Modern Cisco routers and switches come with different types of console ports. Depending on the model, you might have a traditional RJ45 to USB console port. For this lab, we'll be using the main console port with a USB to Ethernet console cable to connect the router or switch to our computer. To connect your router to the PC, plug one end of the console cable into your router and USB end into your computer. Next, let's check if the computer recognizes the console connection. Open Device Manager, expand Ports COM LPT section, and look for a USB to serial COM port. For example, COM3 for me, but it could be a different number on your system. To interact with the Cisco device, we need terminal software. There are many options available, but I recommend PADI because it is open source and lightweight tool. Select serial as the connection type. In the serial line field, enter the COM port number you found earlier. Mine is COM3, but yours may be different. Then click open. At first, you'll see a black screen. Nothing will happen until you press the enter key. This will activate the console session and bring up the command line interface of your device. Now that we are successfully connected, let's move forward with the DHCP Inter-VLAN configuration. Now, let's begin by configuring both VLAN using subinterfaces on the router. A subinterface is a virtual interface that is created on the router's physical interface. Each subinterface will be used to route traffic for each VLAN. Subinterfaces are logically attached to physical interface, and they will be used to perform inter-VLAN routing. Enter the following command to create a subinterface. We need to define the encapsulation method for the subinterface. This will allow the router to understand which VLAN the traffic belongs to. We will use 802.1q encapsulation for VLAN tagging. Let's assign the IP address to the subinterface for VLAN 10. This will serve as the default gateway for devices in VLAN 10. Now, let's repeat the process for VLAN 20. At this point, we've set up subinterfaces for VLAN 10 and VLAN 20. Next, let's move on to configuring DHCP to automatically assign IP addresses to the PC in each VLAN. DHCP allows devices that join the network to automatically receive an IP address without manual configuration. DHCP can be configured on a dedicated server, a layer 3 switch, or directly on a router, as we're doing in this tutorial. Since our router is acting as the gateway for both VLAN, it will also function as the DHCP server for the network. Now, let's create the DHCP pool for VLAN 10 and assign the necessary network information. I always exclude certain IP addresses from being assigned dynamically. This prevents conflicts with critical infrastructure devices like default gateways, switch management IP, or static devices. So we'll exclude the first 10 IP in each subnet. This ensures that addresses from 1 to 10 in each subnet will not be assigned to any client devices. Now, let's do the same for VLAN 20. Before we finish on the router, make sure physical interface is not shut down. If it's down, clients won't receive IP addresses. My interface is already up and running. Now that DHCP is up and running on the router, let's move on to the switch configuration to assign ports to the correct VLAN and enable trunking. Just like we did with the router, first connect console port on the switch and USB side to your PC. As shown in our diagram, port 24 is the uplink, and we will configure it as a trunk. Let's get started. You can see that our switch has been reset and currently has no configuration. This is the initial setup mode, which is not really recommended. Let's select No and press Enter to skip it and move forward. Now we need to enter Enable mode to start configuring the switch. At this point, we are ready to begin the configuration. But first, we need to check how the switch ports are displayed. Some of my interface numbers may be different from yours, so to verify, let's use the show run brief command to display essential information. Now that we know the interface numbers, let's create both VLAN using the following commands. First, we define VLAN 10 for IT department and VLAN 20 for management. Once created, we will assign them appropriate names to keep our configuration organized. Since we are in configuration mode, if I type do show VLAN brief, we can see that the VLAN have been created. This command provides a summary of all VLAN configured on the switch, including their VLAN ID, name, and assigned ports. It helps verify that our VLAN exist and are correctly assigned. Now that the VLAN are in place, let's proceed with configuring port 24 as a trunk using the following command. Next step is to assign port 1 to VLAN 10 and port 2 to VLAN 20. These ports will be configured as access ports. An access port is a switch port that is assigned to a specific VLAN and carries traffic for only that VLAN. Unlike a trunk port, which can carry multiple VLAN, an access port ensures that any device connected to it is strictly within the assigned VLAN. Now, let's proceed with configuring these access ports. We're done with switch configuration, so now let's connect our PC to port 1 to test DHCP. To ensure we are using only one interface, I'll disable Wi-Fi first. Now let's open command prompt on the PC and type ipconfig/all. Sometimes DHCP takes a little time to establish the connection, so be patient. Now we can see that DHCP is working successfully because our device has received an IP address starting with 11, which aligns with our DHCP exclusions from 1 to 10. Additionally, you'll notice that DHCP has leased all the network details exactly as we configured. Next, let's connect to port 2 assigned to VLAN 20 and repeat the test using the same command in command prompt, ipconfig/all, but if you prefer to see less information, you can simply use just ipconfig. This one is also successful. And that's how you configure DHCP with VLAN with Cisco switch and router. Make sure to keep practicing and don't forget to like, subscribe, and share this video so YouTube can recommend it to others.